Welcome. This is Algebra 2, Chapter 6, Section 2, Page 2. Here we have example 1, where we are meant to use those properties of exponents that were on page 1. In this first example, part A here, we have a situation where the powers are being multiplied with the same base. So that means we need to keep the base and add the exponent. And 1/2 plus 3/4 is 5/4. And that's pretty much all we can do with this problem. In problem B is next. And in problem B, we have a product that is to the third power. So the first thing we need to do is understand that the third power applies to each of the pieces. So that's 7 to the 2/3 to the third. And then on the other side we have 5 to the 1/6 to the third. And then going back to that 7, power of a power means we're going to go ahead and multiply the exponents. So it's 2/3 times 3. And then for the 5, we're also going to multiply the exponents. So it's 1/6 times 3. Going back to the 7, we're talking about 7 squared, because 2/3 times 3 is 2. And the 5, it's 5 to the 1/2. And we can finish this just a little bit more, because 7 squared is a relatively nice number. It's 49. So our answer is 49 times 5 to the 1/2. All right, that's what's going on B there. For part C, we're meant to show how things work when we divide. And of course, dividing means you take the same base and the exponents subtract. So it's 5/6 minus 1/3. So that's going to be 3 to the 5/6 minus 1/3 is 1/2. Probably we'll want a calculator for that, but if you remember middle school fractions really fondly, you can do that separately on the side. But anyway, it's 3 to the 1/2. That's all. You could write square root of 3 if you wanted to, but no need really. All right, here's what's going on. On number D, we have two different things, but they're to the same exponent to the fourth. So the book's looking to have you recognize that because the property applies both ways, we could do 16/4 to the 2/3 and have that all be to the fourth. And the benefit of doing that is we can then notice that 16/4 is 4, because 16 divided by 4 is 4. So it's 4 to the 2/3 to the fourth. And so that's the same thing as 4 to the 2/3 times 4, because the power of a power is where the exponents multiply. So it's 4 to the 8/3. That's our answer there on D. Now at the bottom, I have a couple quick things about properties of radicals. The first property is if you're multiplying two things inside a radical, that's the same thing as having two separate radicals with that same index, so the same nth root, but two separate radicals multiplied together. Similar idea here on the right. If you're dividing, it's two separate radicals being divided. And the reason why will come true here in the next example, which I need to bring up on the bottom half of your page. First of all, you'll see on part A here that they're both fifth roots, and it's 27 for one of them, 9 for the other. The point being you can make it 1/5 root of 27 times 9, and that makes the 5th root of 243. And the 5th root of 243 is actually a nice number. It's in fact just 3. That's the product property from the box just above on your page. In contrast, on part B, it's a quotient property we're using. So since they're both cube roots, we can make it one big cube root of 192 over 3. And since 192 divided by 3 is 64, it's really just the cube root of 64, which is in fact just 4. That's what's going on there for example 2. See here, for this checkpoint, we're meant to notice that we could do a couple things here. Since on number 1 here, since they're both in fact to the 6th power, we can go ahead and take 6 times 5, put them together to the 6th power, and have that all be to the negative 1/6. The benefit of that is, first of all, 6 times 5 is 30. One nice number to work with. That's 30 to the 6th to the negative 1/6. And so that's 30, and here we have a power of a power, so the exponents are going to multiply. 6 times negative 1/6. So that's 30 to the negative 1. And so that's just 1 over 30. And I should have had some like equal signs along the way to show that one goes to the next. So our answer is 1 over 30. Number 2, same basic idea going on here, but in fact on number 2 it's a division problem and a square root, and using the second property above, we can make it one square root, where it's 245 divided by 5 inside the square root, and 245 divided by 5 is 49. And the square root of 49 is 7. And that's our answer. Thank you for watching.